Okay, so we are looking at, graphing. And with our graphing, we're really only adding one little new thing today. And that new thing that we're adding is holes. Okay? So holes is another, holes is another type of discontinuity. So for example, our vertical asymptotes are discontinuity because our domain stops at them. So holes is another place where it might stop our domain. So what is a hole? Or how do we find it? Just jump, always. Okay, there we go. Let's hope that. So a hole is just a hole in the graph. We'll kind of see how we draw those. Occurs when the numerator and the denominator have common factors. Right? Factor or factors. Okay? So if I have something that is the same in the numerator or the denominator, it cancels out, and that creates this hole in our graph. Okay? And it's again because I would be dividing by 0, but I also have a 0 in the numerator then. It's a very weird situation. Okay? So, our first step is still the same. Horizontal asymptote. Okay? This is a degree equals 2. Degree equals 2. Again, degrees are our exponents. So then y equals coefficient divided by coefficient. Our coefficient here is 2 and 1. And 2 over 1 is 2. Remembering that we then want y equals 2. We always want y equals as our answer. So I'll graph that. Now, step 2 is slightly different. Now we want to find our holes, and we're going to do that by factoring the numerator and the denominator. Fine. So if I factor my numerator, this is just like simplifying. I'm going to take that 2 out. I have x squared so I have a 2 here. 2 and 3, add to 5, multiply to 6. Okay. 2 and 1, multiply to 2 and add to 1. Okay. So my whole is what they have in common, if anything. Not everything will have a hole. Okay, so this hole is that we want to use that factor x plus 2. And then just like our vertical asymptote, we set it equal to 0. So that is our whole. Vertical, let's make that uppercase A, vertical asymptote. So now I take what's left. I now have this 2 times x plus 3 over x plus 1. I'm going to take that x plus 1 and set it equal to 0. X equals negative 1. That is my vertical asymptote. Step 4 is still points. Okay, here's the special thing. One of your points has to be your whole. Okay, so the first thing I'm going to do is f of negative 2. I'm going to use this simplified function. You don't have to do this whole difficult thing. Use your simplified one. So that's 2 times negative 2 plus 3 over negative 2 plus 1, which equals negative 2 plus 3 is 1 times 2 is 2. Divided by negative 1, I believe that's negative 2. Okay, good. Use a calculator if you need. Then this whole gets an open circle. You don't put a dot. Negative 2 gets a nice big open circle around it. Our graph doesn't touch that point. Now I can continue to find other points. Okay. So I'm going to do, we did f of negative 2, let's do f of negative 3. Equals 2, and then negative 3 plus 3 over negative 3 plus 1. Well, negative 3 plus 3 is 0, times 2 is 0, divided by anything is 0. Oh, that was easy. Let's do one on the other side. Let's do f of 0. Where do I have room? Let's see, do I have room on the other side of this? Not much. We'll do it along the bottom here. 2 times 0 plus 3 over 0 plus 1. 0 plus 3 is 3, times 2 is 6, divided by 0 plus 1 is 1, so 6 divided by 1 is 6. So at 0, I'm at 6. And let's do 1. Again, you could pick any points really as long as they're kind of on both sides, right, of your vertical asymptote, all of those things. So f of 1 is 2 times 1 plus 3 over 1 plus 1. 1 plus 3 is 4 times 2 is 8. 1 plus 1 is 2. 8 divided by 2 is 4. So at 1, I'm at 4. Right? And I'm going to connect these, right? So I'm swooping in here. I can't go through that circle. I have to like kind of jump across that open circle. And then these points I can go through. Okay? So there's a difference between random points we find and our hole that we find, right? It is actually a hole in our graph. Okay? I know these are long. Let's do another one. Example 2. Step 1, horizontal asymptotes. Our degree equals 2. Our degree equals 2. So y equals coefficient over coefficient. which equals 1 over 1, which equals 1. So y equals 1. Wholes. Well, this is difference of squares. Right, so x squared minus 4, if I take the square root, right, I get x plus 2 and x minus 2. Right, same thing here, I get x plus 3 and x minus 3. Okay, here I have nothing in common. So there's no wholes. Okay, so wholes only occur, we're not going to have a hole every time. Wholes only occur when we have common factors. Okay, so then we have our vertical asymptote. Right now, this is my denominator, right? So we still have x plus 2, x minus 2, x plus 3, minus 3. So I have x plus 3 equals 0, x minus 3 equals 0, right? So we still only have to factor the one time. If we've already factored here, I don't need to factor again here. So it's really not that much extra work. It's just another extra thing we have to think about. Gotta subtract my 3's. Gotta add my 3. So I get 3 and negative 3. Then we have points. And I don't have any holes, so I do not have to worry about choosing a specific number. I'm going to start with f of negative 5. Why not? Right? So we have this function, right? So I have negative 5 plus 2, negative 5 minus 2 over negative 5 plus 3. Minus 3. Alright, you can type it all in your calculator, but negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7. Negative 2 times negative 8, which equals 21 over 16. Okay. I know that's right in between 1 and 2. So it's positive, right in between 1 and 2. Again, you can feel free to use a calculator. I'm just using what I know about fractions, 1.3, right? So it's between 1 and 2, close enough here, right? And then we do negative 4. So negative 4 plus 2. Negative 4 minus 2. Right, plugging it in here, I have negative 4 plus 3. Negative 4 minus 3. So that's negative 2 times negative 6 over negative 1 times negative 7, and that is 12/7. And that's also between 1 and 2, but closer even to 2. Okay. Let's do negative 1. Why not? Or negative 2. I'm just kind of going down the line of my points here. Negative 2 plus 2. 2. Negative 2 plus 3. Negative 2 minus 3. 0 times negative 4 over 1 times negative 5. And that's going to be 0. That's easy enough. Anytime there's a 0 in it. So at negative 2, I meant 0. And then I'll do negative 1, and I get negative 1 plus 2, I don't know why I put parentheses around that specifically, negative 1 minus 2, negative 1 plus 3, negative 1 minus 3, negative 1 plus 2 is 1, negative 1 minus 2 is negative. Is that negative 2 or not? No. Negative 1 times minus 2 is negative. Oh, we have 3 spaces. Sorry, I'm going to have to do another point. Negative 1 minus 3 is, so that's negative 3, sorry, it's negative 4, I'm going crazy, over negative 8, which equals positive. Oh, that's fine, okay. I forgot to do over here. Sorry guys. So let's just pick f of 4 really quick. 4 plus 2, 4 minus 2, 4 plus 3, 4 minus 3. I forgot I had 3 different spaces. That's 6 times 2 over 7 times 1, 12 over 7. Right, so it is that mirror image of that. So this is going to look like this. This middle part, right, we have probably our usual middle part, and then this part over here. Sorry that we had to do an extra point, but that gets us enough points there. Alright, let's do one more example. First of all, horizontal asymptotes. I have a 2 and a 2, right? So I'm going to do y equals the coefficient over the coefficient, which equals 1 over 1, which equals 1. So y equals 1. Is my horizontal asymptote. Then holes. I want to get this factored. X minus 3, x plus 2. This is at x minus 4x plus 2. They both have this x plus 2. So x equals negative 2 is where our hole is going to be. Vertical asymptotes, I now have x minus 3 over x minus 4. I take my denominator, x minus 4 equals 0. Okay. Points. Well, one of my points, again, has to be the hole that I'm at. So I have to use this as one of my points. So f of negative 2 equals, I'm just going to use this. I have negative 2 minus 3 over negative 2 minus 4, which equals negative 5 over negative 6, which is about 5/6. So at negative 2, 5/6, there's a big hole. Now I can choose any other points. I'm going to choose one close to my vertical asymptote. Let's do f of positive 2. So that's 2 minus 3 over 2 minus 4. That's negative 1 over negative 2, which equals 1/2. Let's look at 5. 5 minus 3, or 5 minus 4, equals 2 over 1, which is just 2. And then I'll do 6. 6 minus 3 over 6 minus 4, just 3/2. So that's between 1 and 2. So you're coming this way, I gotta completely skip my hole, make my downward. That is it. Alright, we'll probably look at some of these in class if we need to for more examples. Otherwise, that is it for now, and I'll see you guys on